Here again we see the process of adding 1, 0, 1, 1 and 1, 1, 0. 1 and 1 makes 1. 1 and 1 makes 1, 0, so we put the 0 here and carry the 1, which adds to the 1, giving us 1, 0. We put the 0 here, we carry the 1, add the 1s, we get 1, 0. The arithmetic that we use in adding and subtracting binary numbers is summarized right here. This is all we got to know about addition and subtraction. 0 plus 0 is 0, 1 plus 0 is 1, 0 plus 1 is 1, just like in base 10 arithmetic. The only difference is 1 plus 1 is 1, 0. Now, if 1 plus 1 is 1, 0, then 1, 0 minus 1 has to equal 1. So we've got this little surprise from here for binary arithmetic, okay? And then 1 minus 1 is 0, 0 minus 0 is 0. And of course 1 minus 0 is 1, which I haven't written down here. Keeping those facts in mind, let's do a couple of subtractions, okay? 1, 0, 1, 1 minus 1, 1, 0. 1 minus 1 is, 1 minus 0 is 1. 1 minus 1 is 0. No problem so far. Then we got 0 minus 1. What we're going to do with that? Well, we can't do 0 minus 1. We've got to borrow 1 over here. And 1, 0 minus 1 is 1, of course. And now we've borrowed that 1. We're done. Slightly more complex example here. 1 minus 0 is 1. 0 minus 1, we have to borrow the 1 from over here, which we'll replace with a 0. And we write down 1, 0 minus 1 is 1. Again, that becomes a 0. Then 0 minus 0 is 0. 1 minus 1 is 0. And we have the 1 here, minus effectively a 0 down here, giving us this result. We can do multiplication in base 2, although this sometimes gets us into adding a lot of 1s, and we've got to be careful when we do that. Okay, multiplication is just like with, in other words, the algorithm for doing multiplication is just like the one that we use in base 10 multiplication. 1 times this number just gives us this number. 1 times this number here gives us this number, but of course we move it over a place to indicate that it's in the next place value. 0 times the number gives us 0. We're going to go ahead and fill up its places so that we get this one lined up right. 1 times the number then goes down here. We've got our columns lined up, and we simply start adding. 0, 0, 1 and 0 is 1. Now 1 and 1 gives us what? Gives us 1, 0, so we write down the 0 and carry the 1. 1 and 1 gives us what? 1, 0, so we write down the 0 and carry the 1. Now let's see what happens. 1 and 1 is 1, 0, as we know. We add another 1, and what do we have? Well, 1, 0 plus 1 gives us 1, 1. Carry the 1, and it adds to the 1 here, giving us a 1, 0, and 1 gives us 1, 1. Then 1 and 0 is 1, and we have a 1 here. We were lucky this time. We didn't have to add 4 or 5 1s. But it could occur that we would have to add 4 or 5 1s. There's no reason that that can't happen if we're multiplying a large enough number, so we'd better be careful to see how the arithmetic works. 1 and 1 and 1 is 1 plus 1 plus 1. 1 and 1 is 1, 0. 1, 0 and 1 gives us 1, 1. If we add another 1, it's like we got a 1 plus 1 and a 1 plus 1, which is a 1, 0 plus a 1, 0. If we add that up, we get a 1, 0, 0. Now, of course, that's a representation of what we call 4, and this is, of course, 4. Then 5 1s is going to add up by similar breakdown to 1, 0, 1. We could break it down to 4 1s, which is a 1, 0, 0, plus a 1, which is going to give us a 1, 0, 1. You should continue this table down, maybe 10 lines or so. Make sure you understand the pattern that you get when you add a bunch of 1s. We can also do long division. And there are little complications that come in when we do long division, okay? 1, 1 goes into what? It won't go into 1 because it's got to go into something that's bigger than 1, 1. The first number we get here that's bigger than 1, 1 is 1, 0, 1. So 1, 1 will go into 1, 0, 1. We conjecture 1 time. Better just be 1, because if we had 2, we'd be in trouble because we don't have a 2 in base 2. Okay, 1 times 1, 1 gives us 1, 1. We subtract, we get 1, 0, 0. Now 1, 1 will go into 1, 0, 0 since 1, 0, 0 is bigger. 1 time. Then we subtract the 1, 1, and we get just a 1 here. Bring down a 1, and we get a 1, 1, which is the same as what we're dividing by, so we get another 1 here. Write down the 1, 1 down here, and we get 0. 0, 1. Well, 1, 1 won't go into 0, 1, so we get a 0 here. And then we subtract down here, and we get a 1, 0. And 1, 1 doesn't go into 1, 0, so we have a remainder of 1, 0. It could have happened, but it didn't on this example, that we'd go another line. If we had another line here, we'd have a 1, 0, 0, and 1, 0, 0 minus 1, 1. Well, we can figure that out using the subtraction algorithm. It wouldn't be too difficult. But by analogy, in base 10, 1,000 minus 999 is 1. 999 means that the 3-place number is full, in a sense. If we subtract then 999 from 1,000, we get 1. If this was 1, 0, 0, 0 minus 1, 1, 1, what would we get if it was a base 2 number? We'd get 1 again, and you might think about why that holds. Another thing that you should certainly do is list the binary numbers and their decimal equivalents. You should be able to count binary 1, 1, 0, 1, 1, 1, 0, 0, 1, 0, 1. If you do this exercise, figure out what 9 would be, then figure out what 10 would be, and write these numbers down, you'll see a pattern emerging, which is in some ways very similar to the pattern we get when we do trues and falses on a truth table. And you might think about that analogy a little bit.